Yes, dear viewers, welcome to this presentation on refractive index of a glass prism by using ID curve method. We are 4 in the group, and my name is Jones from Tanzania, but the other members are Masam from Zimbabwe. Yes, welcome, sir. We have Chigwinya from Zimbabwe. Welcome, sir. And we have one lady from Bangladesh named Nasima. Thank you, Brother Chigwinya will take us in the experiment step by step. So welcome and enjoy.
We are going to determine the refractive index of a glass prism. As you can see, a glass prism is comprised of 3 rectangular surfaces which are bonded together to form a triangle. So we are going to look at how light is refracted as it moves from one medium into another. In this case, we are going to see the movement of light as it moves from air and then through our glass prism. We are going to define what is meant by refraction. Refraction is a concept which refers to the bending of light as it moves from one medium to another medium of different optical density. Refraction is a result of the change in velocity as light passes from one medium onto another medium. So in this case, we are going to use air and the glass prism. In this case, the glass prism is more optically denser as compared to air. I'm going to introduce the materials required for this activity. Right, we have a pencil, we have protractor, and then of course we need pins, right, and then we also need the glass prism. Now that we have our apparatus, the next thing is to go straight away into the experiment. The first stage is after having secured our drawing papers on our board, the next stage is I am now going to draw my horizontal line through the center of my paper, right, and then I draw my line, right, and then I'll call this X, Y. And then through the center of XY, I am going to mark my point, which I'm going to call O, right. And then, after having done that, I am now going to draw my normal line, which passes through O, right. So, I'm going to mark my angle of 90 degrees, all right, and then I draw my normal line, right, like that, right, and then I might just call it L0, right. Having done that, I'm now going to start with an angle of 35 degrees for my incident ray. So using my protractor, right, I am going to measure an angle of 35 degrees, which is, you have to be very sure, which is somewhere there, right, and then I will draw my line passing through O, like that, right. Having done that, I am now going to use my prism. Right, and then I will place it, making sure that I'll place it on my board like that. And then first you have to mark its edges like that. And then after having done that, I'm going to place my pins. This one I will call it pin 1. Alright, and then this one I will call it pin 2. We want to investigate the movement of light as it moves from one medium to another. So through this other face of my prism, I'm going to locate the images of P1 and P2, and then I'll be able to locate the movement of light as it emerges from the prism. So in order to do that, I will look through the prism from this angle, and then with one eye closed, I will locate the 2 pins. Right. So I will have 2 pins again, P3 and P4. Right. I'm going to locate now my pins as they appear in my prism. Right, like that. All right. So this one is P3, and then I'll use again P4. So P3 should be in line with the images of P1, P2, and also should be in line with P3. So this is my P4. You have to be very careful. Right. Like that. After having done that, you have to make sure that you circle your points and you mark them. So this is P1, and this is P2. Right. This one is P3, and this one is P4. Right, and then for my prism, this point is A, this one is B, and this one is C. Right, and then you connect P3, you connect P3 and P4 like that. All right. So this one is the incident ray, and then this one is the emergent ray. So as you can see, when extended, the incident ray will meet the emergent ray, and they make an angle which is called the angle of deviation, which is angle D. So for angle of deviation, and then I'm going to measure the angle of deviation using my protractor. Right. So maybe this one I should call it first. I'll call it This one is L0, L1. Right, I just call it again L1 from here. Right, so I'll measure the angle of deviation, which is this angle where the incident meets the emergent ray. So this is my angle from this point. Right, so I'll use my protractor to measure that one. Right, as you can see from my results, this is making an angle of 44 degrees. Right, so we record that. So 35 degrees here, incident, which is 35, and then here our angle D is 44 degrees. Right, having done that, you repeat the same procedures but changing the angle of incidence. 35, move on to 40, 45, 50, 55 up to 60. You don't have to exceed 60, and the minimum should be 30 degrees. From our experiment, as you can see from the table of results, we have angle of incidence and deviation. For an angle of incidence 35, we had 44 degrees as our angle of deviation. 40, 42, 45, 38, 50, 38 again, 55, 40, 60 and 41. So our next step is to plot a graph of angle of deviation against angle of incidence, and from that graph we are going to determine our minimum angle of deviation, which will enable us to calculate our refractive index of our glass prism. Now we're going then to plot our graph of angle of deviation against angle of incidence. As you can see from our graph, we have obtained a curve. Then from the curve, we are going to identify the angle of deviation minimum. This is the minimum point. So we take this angle deviation minimum, which is about 37 degrees, and then we are going to use it to calculate our refractive index of the glass prism. That is our next step, to calculate the refractive index of a glass prism using our angle of deviation minimum, which is 37. From the graph, we have established that our deviation angle is 37, and then our angle of prism is 60. So we are going to substitute those two values into our equation so that we can calculate our refractive angle. So by substituting, we get sine 60 plus 37 all over 2, and then sine 60 over 2, right? And then after simplifying that, final answer, which is the refractive index, 1.5. That is our value of the refractive index of the glass prism. From these results, it can be concluded that the refractive index of a glass prism can be determined using the ID curve method.
Precautions:
the angle of incidence of incident ray should lie between 30 degree to 60 degree.
the pins should be fixed vertically, and the pins pricks should be encircled after they are removed.
A minimum distance of 10 centimeter should be maintained between the two pins.
Arrowheads should be marked to represent the direction of the incident and emergent rays.
For all observations, you should use the same angle of prism.